So let's see whether we can do some simple estimates of flushing times in positive estuaries. Okay, so you're employed as an environmental consultant and you get the request to estimate the flushing time of an estuary. You don't have access to a computer, or you don't have the skills to run a hydrodynamic model. Okay, but here are different two other ways to do it. Yeah? So how do you work out the flushing time? What is flushing time again? So imagine you have a certain volume. This is the volume of your estuary. How long does it take to fill up this volume? Okay. It's easy if you imagine that you have an empty bottle and you fill it in. Yeah, you just add some other stuff. Okay, but a positive estuaries essentially has three openings. Okay, so it's unlike a bottle which has one opening. This has three openings. There's one connection to the river. Okay, and this is what we call R in these sketches. Then there's an outflow in the ambient coastal ocean we call Q1, and there's an inflow of seawater from the ambient ocean that we call Q2. And these are volume transport. How many cubic meters of water per time unit per second are injected into your estuary or leaving the estuary? And in terms of flushing time, what we use is we actually use the inflow of seawater as a source of new water, because the river water itself can be polluted. It's often a source of pollution, and we use Q2 as the source of new water. So you work out the flushing time from the ratio of the total volume that you have and the Q2, which is the volume transport of the incoming, inflowing seawater. Okay? So this is how you can put your model. You can go out and try to measure these transports. It turns out to be very tricky because of the tides. You have to do measurements over several days, and I want to show you a method where you can measure the salinity and work out flushing times from your salinity observations. Sounds totally weird and crazy, but there is a way and there is a justification for this method. Okay, let's have a look.